All right, my friends, let's take a look. I've labeled this triangle with A, B, and C for the angles there. And so let's look and see what happens if you try applying the law of sines. So sine of A would go over 5.1. Sine of B would go over 7.9. And sine of C would go over 3.5. And as you can see, you can't get a complete ratio. And so any proportion that you choose from here, you'll end up with two unknowns. And so the problem is because you don't have a complete ratio. All right. So in situations like this, where we can't apply the law of cosines, and I hope it makes sense, we can't apply, basic trig either. We can't just use sine equals opposite over hypotenuse or anything, because we have no reason to believe that this is a right triangle. And in fact, it isn't a right triangle. So we wouldn't want to use basic trig. So enter, dun, 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 the law of cosines, which is a little more complicated than the law of sines, which is why you'd want to make sure you can't use something simpler before you go kind of for the bigger stick, right? So in this lesson, I'm going to introduce what the law of cosines is in its formulaic sense. And then after that, I'll have you watch a video where someone shows a derivation of why the rule is the way it is. And then after that, we'll have one more video where we show you an example where you use it. And then that'll be it. So this will be a relatively short lesson. So, all right, my friends. So let's talk about the law of cosines. Okay, so law of cosines is used for, I guess you could use it on a right triangle, but that would be kind of goofy. So it's used for an oblique triangle. So I'm trying to draw this, so it's quite obviously not a right triangle. And then let's label, remember the letters kind of correspond. The length opposite angle B would be called B, etc. Okay. So law of cosines actually has, I think, like many versions. I think your textbook publishes 6 different versions of what I think of as just one formula. So I'm not big on memorization. I'd rather be good at processes because I think they're more empowering. So anyway, so what I'll do is I'm going to show you first the formula that I have memorized, and then I'll show you how I kind of cheat off of that one to get any of the other ones. Okay. So the law of cosines, the one that I find easiest to remember, starts with length C here. And the reason I find it easiest to remember is because at the beginning, it looks exactly like the good old-fashioned Pythagorean theorem. It says C squared equals A squared plus B squared. But I think we all know that if this is not a right triangle, which it isn't, then that cannot be the end of the story, right? So we're going to see some error being subtracted off. And in the next video, you'll see an explanation algebraically as to exactly why this is here. But you'll see some error subtracted off. And it's of the form 2 times whatever length is right there times whatever length is right there. So 2 times A times B, and then times the cosine of whatever angle would be opposite that length that you started out with, which in this case would be angle C. And that's the pattern. That's it. Anyway, so, and then there are 2 other versions that look like this, and but they're the same story. Okay, so like another version of law of cosines where you're solving for length A would start with A squared. And then it would have the other 2 lengths squared, the sum of the other 2 lengths squared. And then you'd have minus, so now's your error here, 2 times B times C, see these lengths, same pattern, and then times the cosine of, guess what angle? Yeah, angle A there, okay? Same pattern. So let's have you use the same pattern to figure out what the law of cosines would say, the version of it that starts out with B squared. I'll give you a minute. So yeah, B squared would equal the sum of the squares of the other 2 lengths. And then you'd have error being subtracted off of the form 2 times A times C times the cosine of angle B. There you go. All right, my friends, so though this is the law of cosines, there's another version that's commonly published. It's where somebody just algebraically solves for the cosine of C, cosine of A, and cosine of B. But I figure we're good at algebra, so why memorize those if we're just super good at algebra? Let's just know these. How about that? There you go. Hopefully that makes sense. All right, next video, they're going to explain why exactly the formulas are the way they are. So I hope you enjoy it.